Hey everyone, welcome to how to graph exponential functions, part one. This is just y equals b to the x, where b is going to be greater than 1. This is Nicholas, JMV. So let's go ahead and get started. Okay, so the graph that I gave you, f of x, b to the x, where b is greater than 1, is actually exponential growth. And this is kind of what the family is going to look like. Okay, so there's some key things going on here. It's going to be exponential growth because the b value, what's being multiplied repeatedly, is larger than 1. Okay, so the other thing we have is the domain is all real numbers. There's nothing that will make this function not work, so it is continuous, and it's also 1 to 1. The range, however, you notice this function gets really close to the x-axis and stays above. The range is positive real numbers, and there's actually our asymptote at y equals 0. Now, there's some key points that you can graph just quickly to get the general sketch of that graph, they being -1, 1 over b, 0, 1, and 1 over b. So we can use this idea when we're graphing functions. So let's go ahead and look at two examples that I have for you today. So the first function is we're going to sketch the graph of y equals 4 to the x, state the domain and range. So what we can do here is the domain and range is pretty simple. We'll call it y. So I can go ahead and I'm going to just up here write the domain of y is going to be all real numbers. Okay, it's an exponential function. That's what we know. The range, we haven't done anything to it. It's going to be from 0 to infinity. Okay, positive real number. So when you graph a function like this, we can look at our b value being 4. So the first point, remember the key points they told us was 0, 1, which is right here. So 0, 1, 1, comma b. Well, our b value is 4, so 1, comma 1, 2, 3, 4 right here. And then the other point was -1, comma 1 over b. So 1 and 1/4. Now, -1 and 1/4, that's down here. That's going to be pretty close. So the general sketch, I'm going to make a smooth curve, and this is going to shoot up. And there's the graph of that function, y equals 4 to the x. Okay, so just some key things to pick out here. So let's go ahead and look at one more. Okay, now y equals 3 to the x. There's a lot of ways you can do this. I could make a table, right? If maybe I'm confused, I could say, all right, let's make a table this time and say, well, what happens when I use like -1, 0, 1, 2? Well, if I plug in 0, 3 to the 0, anything to the 0 power is 1. Plug in 1 for x, 3 to the first is 3. You plug in a square, you get 3 squared is 9. So I would have enough to do that. And then if I use -1, 3 to the -1 power is 1/3. So be very careful here. It's not negative. Okay, so you can create a table of values, and I've got enough to graph. And remember the key points. There is 0, comma 1, right? Here is 1, comma b. And then there was the 1, comma 1 over b right there. So there they are. You can get them from a table of values. You can try to memorize the key points. It's up to you. So we have 0, 1, 1, 3, 2, and 9 is going to be pretty high to get, and -1 and 1/3 maybe here. That last one is going to be an estimate, okay? So that's a little bit harder to graph accurately, so I make my smooth curve. Okay, not as steep as the last one. That other point would have come up right here. See, the other graph and the previous one has shot up quicker. Okay, it asks you to state the domain and range. The domain of y, again, is going to be all real numbers, okay? And the range of y is just going to be 0 to infinity, positive, right? Okay, so that's how we graph general forms of y equals b to the x for exponential growth. Stay tuned for the next video, and we'll show you how to do exponential decay. Questions or comments, let me know. We'll see you next time.